Hello world, Nick here with video number 6 of my Java programming tutorials. And today we're going to talk about two things. First, we're going to talk about this thing called casting, and then we're going to talk about some more of the arithmetic operations we can do. The only one we've really gone over is addition, but there is also multiplication, subtraction, division, and taking the modulus. So division behaves a little interestingly, has a few special cases, and taking the modulus is probably completely new to most of you, so figured we should give that its own video. But let's get started with casting. So casting is where we take a variable of one type, and it has to be a primitive type, so it can't be string, and we squeeze it into the shape of another one. And there are a few reasons we would want to do this. Let's say we have a string and we want to get the character that's at position long, my long equals 74. We want the character at position my long. Well, if we tried to do this right now, we would get an error because we have to remember that string dot char at takes an argument of type int, and this is a long. But 74 fits into an int, so there should be some way to just easily tell Java that we just want to make it look like an int, right? Well, that's what casting is for. So let's write the variable we want to cast it as. Int my int equals. So if we just put my long like this, we're going to get an error. Because even though 74 fits into an int, Java doesn't know that. It could just as easily be a number that doesn't fit into an int. And that's what this error is basically telling us. It's saying you can't convert from a long to an int. But something interesting, if we put a short here, then it would be okay, because every short fits into an int, so Java knows that nothing tricky is going to happen. It just lets us do it. But with the long, it wants us to make sure we know what we're doing. Because if this number is too big, the number stored in the long, then it might not be what we want it to be when we stick it into an int. Because if the int can't hold it, then it's probably not going to be the value you expect. So how do we explicitly tell Java, hey, I want this number to be an int? Well, all you have to do is before the number that you want to cast, so this is the one we want to make look like an int, we just have to put int in parentheses and then a space, and now that's us telling Java, hey, I want this to be an int. And this doesn't actually change what my long is. My long is still a long, but when we put the int before it, we're just saying right here, this phrase right here, let's take the value of my long and let's treat it like it's an int. So that's just to show you what I'm saying. Here's our string, and then let's use the char at. So Java tells us like what methods there are and kind of what they do. This is all straight from the documentation. So it's pretty nice that Eclipse does this for us. This is one of the benefits you'd get if you used an IDE over using just a text editor. But here, so we have str.charat, and it takes an int. So if we put in my int, we should be fine. Now, if we actually called this, we would get an error of some sort, like if we actually ran this program. Let's run this program and see what happens. Yeah, so we get exception in thread main, string index out of range, 74. And that's because the string is only 3 characters long. So it only has index 0, 1, and 2. And 74 does not fit, that's out of range. But it does show you that my int does actually just hold 74. But now what happens if we try to put my long in there? You see, we get this error because it's not applicable for arguments of type long. And even though we casted it here, my long is still technically a long. It's only this part right here. And another thing we could do is we can cast it right here where we're using it, just like that, and we don't even need this variable then. But it might still be good to get in the habit of making separate variables, since if you just keep putting everything on the same line like this, it can get pretty complicated pretty fast. But that's one instance where you would cast. Another instance where you would cast is if we have a double and we want to make it look like an int. So what happens if we have double, my double equals 7.5 or 7.6, and then we have int my int equals, and we want to set it equal to my double. Well, obviously that can't happen exactly because 7.6 is not an int, and here double will tell us you can convert from a double to an int. But if we try to cast it, let's see what happens. It works, which is weird because we know ints can't hold 7.6 because 7.6 isn't an integer. Let's see what happens if we print my int, because it'd be weird if that were 7.6. Well, what we got is 7, and this is the way that Java behaves whenever we take things that should be doubles and we try to squeeze them into ints. It just cuts off the decimal. It always rounds down. So if we put 7.9999 and we ran this, we would still get 7. But if we put an 8, then we would get 8. So it always rounds down. It just cuts off the decimal. That's called truncating. It truncates anything past the decimal point. And another case where this happens is in division. So let's go ahead and get started going into the operations. But first, just one last instance of casting. We can cast characters as ints. And this is actually pretty useful sometimes because let's say we have car x or car my car equals, and we use single quotes for strings. Let's put capital X. Actually, no, let's use a G. And let's make int my int equal my car. But so here the casting seems like it's kind of implied for us, because this is one of those cases where a car is smaller than an int. Remember, a car is 1 byte and an int is 4 bytes, or a car is 8 bits and an int is 32 bits. So because it's smaller, we don't actually have to put the casting symbol, this there, but we can, and it's fine. Nothing crazy will happen. Now let's go ahead and run this and see what we get. So we got 71. So we printed out my int. So my car, when we treat it as an int, is apparently 71. Why? Why does that happen? Well, that's because whenever we take a character and we try to fit it into an int, what we get is its ASCII character value. So the ASCII character value, there's one assigned to each character, and they're pretty intuitive once you kind of get used to them. So if G is 71, then what is H, you think? H is going to be 72. And what if we want to see a lowercase h? So it's kind of weird the way that it works. The lowercase letters are always 26 below the uppercase letters. So right here, let's put minus 26, and that should give us a lowercase h. Or, well, it's giving us 46 because we had Before that, we had 72. But what if we wanted to take a character and make it uppercase, or make it lowercase? Well, here we have the character, and then let's say here my int, just like we had before, equals 26. But we want to see the character version of this. Then let's say my new car equals. Now, if we try to say my int, we're going to get an error because we're trying to squeeze the bigger int into the smaller my new car, and things can go wrong when we do that. So this is Java trying to watch out for us. So we have to go ahead and put car before. And now let's print out my new car and see what we get. We get dot. So that means that if we start at H and we go down 26 from where it is, we get the period. And if we go down 30 from where it is, we get the asterisk, and so on. If you pull up the ASCII character table, this will all make a lot more sense. For now, all that really matters is every character has like one integer that it's just directly assigned to, and yeah, that's pretty much how those work. And if we add 26 to it, we get a lowercase b. So yeah, you can check out the ASCII character table, see how that works there. So I kind of snuck a subtraction symbol in there. It does exactly what you'd expect. Now let's check out multiplication. Multiplication is also works exactly like you'd expect it to. Print out result and say int result equals 4 times 3, and that's going to be 12. And if we put a negative before one of them, we are going to get a negative 12. So it's pretty much what you'd expect. Java does follow order of operations. So if we have, that's a bad example. If we have something like this, it'll do the multiplication first, and then it'll add the negative 4. So you got 3 times 12 is 36, plus negative 4 is 32. That's what we got down here. And yeah, there's nothing too tricky about that. Where things do get a little tricky is with division. So let's do some division. We have 7 divided by 5. Now what happens when you print this out? We got 1. But 7 divided by 5 is not 1. It's 1.4. Why did it say it's 1? Well, we have an int right here. We're saying that result is an int. So we're basically taking this, which should be a double, and we're casting it as an int. Well, let's change this to a double and see what we get. We got 7 divided by 5 is 1.0. But now we're calling it a double. So why does it say 1.0? Well, that's because 7 is an integer and 5 is an integer. So Java is treating them as integers. So when you divide one integer by another, you get the result rounded down. But when we put 0.0 on them, we're telling Java these aren't integers. We have a decimal part to them, even if it doesn't mean anything. So that tells Java, hey, treat those as doubles for me. And that's why now we get 1.4. Now, another interesting case with this is what happens when we divide by 0. Let's say we have 8 divided by 0. What do you think that the result's going to be? Exception. In thread main, divide by 0. An exception is basically Java trying to tell you you're doing something that you shouldn't be doing right now. It's as far as we're concerned right now, it's basically the same thing as an error. So Java doesn't let you divide by 0, which is nice. It tells you that if you ever did try to divide by 0, like, your program probably made a mistake somewhere. And last case we want to look at is something called the mod, or the modulus. If you've ever done anything with number theory before, you've probably run into it. It looks like this. It's the percent sign is how we denote it. And what the modulus is it is the remainder if we divide two things by each other. So here we have 8 modulus 3. So if we did 8 divided by 3, you would get a remainder of 2, because that would be 6, or 8 divided by 3, it would be 2 remainder 2. That's a bad example because the remainder and quotient are the same. Let's do 10 divided by 3. So here we get 3 remainder 1, if we did this the middle school way, and the modulus is 1. And that's pretty cool. So if we just do 1 mod 3, the 1 is smaller, so its quotient would be 0 remainder 1. And when we add negatives, things get a little weird. What's negative 1 mod 3? It's negative 1. What's negative 4 mod 3? It is negative 1 also. So you can play around with this a little bit, see exactly how it behaves when it's negative. You're rarely going to want to use it with negatives though, but you might also want to look at what happens when you put the negative on the first number as opposed to the second number. Does it change anything? Looks like it does, so that's something to look at. But it's all stuff you can kind of work on your own. You just play around with it. But anyway, that's it for this video. Stay tuned for more. I'll see you next time.